Okay, welcome back. In this video, we are doing a conceptual overview for our topic this week, simple tables and figures. We'll also be talking about frequencies. And since this is the first one of these videos, when I say conceptual overview, what I mean here is just the broad concepts of the topic for this week, right? As we go further in the semester, we'll have, I guess, yeah, more sophisticated or maybe more complex statistical analyses. And so I'd like to start with kind of a broad sense of what this is about, what the purpose is, before we get into the technical nitty gritty of how we actually go and do those analyses. So starting with simple tables and figures, two terms that I imagine you're familiar with, probably don't necessarily need an explanation or description. But for the sake of clarity and comprehensiveness, let's do that. So tables essentially are arrangements of information or data, right? We're not talking about kitchen tables here. We're talking about things that look like this, right? So oftentimes in statistical analyses, we have lots of numbers to report. Um, like for example, you might be familiar with correlations. If you're not, we'll cover this later this semester. Um, but one way to report correlations, say I'm doing an analysis and I'm writing some research article about what I did. We could sit there and write paragraph after paragraph detailing every single correlation, but that would be really boring and just take up a lot of space, right? So tables are a much more succinct or concise way to summarize lots of information without having to write all this text about it. And so in this example, average high and low temperatures in Fairbanks, something I pulled off the internet. Um, this, right, like through experience, if assuming you've been in Fairbanks, even if you haven't, right, I think it's fair to assume that we know that winter is going to be colder than summer and vice versa. And so we can look at this individual month by individual month and get a sense of the high and the low and kind of think of it that way. But figures can make that much more intuitive and easy for us, right? And so these are visual depictions of information or data. In this example, it's accompanying the table. And so it's sort of putting an image or picture to that sea of numbers or temperatures that we just saw in the previous slide. And so that's one way we use these in statistics is to accompany tables. Say, for example, if I'm doing some analysis, um, again, if we're just looking at this wall of numbers in a table, it can help us to understand what's happening if you have the right skill set and if you're willing to put the time into it. But figures can be a much more rapid way to communicate information. Um, and also for some people, I think it can help to really consolidate their understanding of what is happening. Because even the best statisticians can sometimes be stumped by tables, right? Like sometimes it's just nicer to look at the picture. And so in APA style, for example, in the journal articles that you'll be exposed to in this and other classes, you'll probably see figures, and a lot of times they're like this example where they accompany a table to provide some more context or information. But that's not the only purpose. Really, they can be any illustration or image other than a table. Say, for example, if you're doing a study and you, as part of that study, you show people pictures, right? Like, for example, some people at UAF in the psych department are doing some studies in which people are seen or exposed to images of nature, and they're asked about their emotional response to seeing those images, right? And then if we're writing up this manuscript, we might include those pictures for the reader. That way, they can see exactly what the participants saw, right? So just one example of some time that it might not necessarily accompany a table. And on the note of tables and figures, one thing that we often see is frequencies. And this really, for me at least, and I think for most people, looking at frequencies is one of the first ways to begin really any statistical analysis to get familiar with your data, right, and sort of what's occurring. And so the term frequency, I think, is intuitive. Like if I asked you how frequently it snowed this winter, you could probably have some kind of answer for that. So in a broad sense here, we're referring to the number of times or how often something occurs. And so that can look different ways. One example is if we're looking at categories or categorical data, that can help us to get a sense of how people responded or how people were grouped in the data. So for example, this is from a study I did. I forget what the topic was, honestly. But looking at frequencies of educational attainment. So in other words, we asked people this question of what's the highest level of education you've attained, and they had these 5 response options. And this table helps us to quickly see how many people responded to the different categories, right? So for example, we can see our category here, education, our counts, our percent of total, and the cumulative percent. So for counts here, we can see that 30 people said that they had some high school at most. 75 said they had a high school or GED. 19 said they had some college. 54 had a 2-year degree, and 8 had a 4-year college degree. Right, and so then if we wanted to think of that in terms of percentages or proportions of the whole sample, because if I just said, okay, 30 people said they had some high school, okay, well, if you don't know the rest of the context, then that's kind of meaningless. And so if we're communicating that to someone, it's much, I'd say, easier or more accurate and precise to report percentages, right? We could say, oh, 16% of our sample said they had some high school at most. And then we can also look at cumulative percent here. Basically, it's just adding these up to 100. So 16% said some high school, 56.5%, or roughly 57%, said that they had at least, or no, sorry, had at most high school or GED, right? Because then we're incorporating this group and the group before it. 67% said they had at most some college, right? Because they either had some college, high school, or some high school, so on and so forth. We can also look at reports of scores. So for example, if we have a 1 to 5 scale from very unsatisfied to very satisfied, we could see the counts of the number of people who said 5, very satisfied. Typically, we wouldn't report just the single number. Um, I guess you might in the paper itself, but in a table, typically we wouldn't have a table with just one of the options. Typically, we have the whole range of scores, like in this table here. So all the scores on a 1 to 5 scale. So you can see this job set one specific item or question on the scale, and you can see 3 people said they were very unsatisfied, 5 were unsatisfied, so on and so forth. And so we can clearly see here, just looking at the percent, that most people were either very satisfied or satisfied, right? Half, 1 out of 2 people said very satisfied, and 40% said that they were satisfied, right? And so, yeah, so just some examples of how we might see this in our work. And you'll also be exposed to this term distribution a lot. We'll talk about it in the context of frequencies, but before we do that, distribution, one of those words that was never really defined for me. People just use it a lot. And so I actually kind of struggled to think of like the best way to describe this. Um, but I think an easy way to think of it is a distribution is like a spread, right? Or a summary of occurrences or observations. So for example, it might be something like this where we're just looking at a spread, right? So say, for example, this is from a Wikipedia page called reindeer distribution, and it's a global distribution of caribou or reindeer. I know there's supposed to be some differences, but I don't know the difference personally. But it's global distribution of caribou throughout Arctic regions and subarctic regions, right? So that's one example of this spread. When it comes to statistics, right, we often, or we'll use this term in different ways for our purposes now. In terms of frequency distributions, you just saw these on the tables before. These are just basically summary displays for group data or ungrouped data. And typically that display is in the form of either a table or a figure like a histogram or a bar graph. So for example, or yeah, before I get into some specific examples, if it helps, like one example I could think of for this that's a little more practical and less related to statistics. Where I grew up, we went trick or treating, and I don't know if that's, yeah, if that's a thing everywhere, but it's something we did where you go door to door, you ring the doorbell, you're dressed up in your costume, you say trick or treat, and then the person, if they're nice enough, they answer the door, and if they're nice enough, they give you some candy, right? And then after you're done, right, we'd go and do that for like an hour or so until it gets dark, and then we'd come home, and the first thing we did was immediately dump out all the candy and see our haul, right? We got to see what we got. My haul was never this big, right? This is insane, but this is something I found online. This is an example of a frequency distribution of someone's Halloween haul, right? All the candy they got. And so you can see they got a lot. And so not only can you see like the sum total, but you can also see how much of the individual items, right? Like here, on the right, we have these Laffy Taffy. So you can see she got five, or they, I don't know the gender of this person. They got five Laffy Taffies, right? And two of those were banana, right? I know banana is a controversial flavor for Laffy Taffy. I'm personally pro banana. I know not everyone is though. Right, but point being, right, you can see the frequencies or the occurrences of the different types of candy she acquired. Again, lots of candy. Some dentist is going to make a fortune off this child when she's an adult, or when they're an adult. And so when it comes to the data we'll be working with, if it's ungrouped, this is typically what we see in spreadsheets or in our data sets when we're working with statistical software, right? So ungrouped is just the frequencies of each individual score in a category, each individual score or category rather, in a distribution. So for example here, I used a spreadsheet program, Excel, to randomly generate 100 dice rolls, right? So I asked it to give me random numbers between 1 and 6 and see what we get. And so the ungrouped is pretty hard to interpret, right? Because we can see there's a lot of numbers here, but it's hard to really get a sense um, without looking more closely of what the most common number was, right? And so grouped data then is typically much more approachable and more rapidly absorbed and understood. So we can see here that shows the frequency of scores falling within defined groups or intervals. In the case of these dice rolls, that's easy because it's just what the roll was, right? Was it 1, was it 2, was it 3, was it 4, 5, or 6? And so then you can see the frequencies, right? So yeah, so for example, the highest here was a roll of 2, and 20 of those 100 rolls were A2, right? So pretty basic stuff, but I think an important foundation on which we can build in the course. One thing I didn't include here was a bar graph or histogram, and so that's another way we can depict this data. So for example, we could actually chart out, okay, like how many people rolled 1, how many rolled 2, and just kind of group it together in a bar graph to make it a little bit more digestible, something that you'll be doing in this module. But for now, we'll stop there and see you in the next one.